What's up, everyone? Welcome back. Today's problem is a beautiful trigonometry puzzle. At first glance, it looks almost impossible, but there's a surprisingly elegant shortcut hiding inside it. Here's the equation we're given. Sine of x raised to the 100th power plus cosine of x raised to the 100th power equals 1. Our goal is to find all possible values of x. Now, you might be tempted to attack this with brute force algebra, but that quickly becomes a mess. Instead of expanding huge powers, we're going to solve the entire problem using a simple inequality. Let's begin with a famous identity that every trigonometry student knows. Sine squared of x plus cosine squared of x is always equal to 1. The question is, how can we connect that identity to our equation? Let's focus on the sine term first. I claim that sine of x raised to the 100th power is always less than or equal to sine squared of x. Of course, in mathematics, every claim needs a proof. So, let's prove it. Consider the difference between the two expressions. Sine of x raised to the 100th power minus sine squared of x. Factor out sine squared of x. That gives us sine squared of x multiplied by the quantity sine of x raised to the 98th power minus 1. Now think about the possible values of sine. Sine of x is always between -1 and 1. So any even power of sine must lie between 0 and 1. That means sine of x raised to the 98th power can never be greater than 1. So sine of x raised to the 98th power minus 1 is always less than or equal to 0. Meanwhile, sine squared of x is always greater than or equal to 0. A non-negative number multiplied by a non-positive number can never be positive. So the entire expression is less than or equal to 0. That proves our claim. Sine of x raised to the 100th power is always less than or equal to sine squared of x. The exact same argument works for cosine. So, cosine of x raised to the 100th power is also less than or equal to cosine squared of x. Now, let's combine the two inequalities. On the left, we have sine of x raised to the 100th power plus cosine of x raised to the 100th power. On the right, we have sine squared of x plus cosine squared of x. But here's the interesting part. Our original equation tells us that the left side is exactly 1. And the Pythagorean identity tells us that the right side is also exactly 1. So both sides are equal. The only way this can happen is if both inequalities are actually equalities. That means sine of x raised to the 100th power equals sine squared of x, and cosine of x raised to the 100th power equals cosine squared of x. Now ask yourself, when does a number equal its own 50th power? The only possibilities are 0, 1, or -1. So both sine and cosine must take values from that set. On the unit circle, that happens only at the 4 quadrant angles: 0, pi over 2, pi, and 3 pi over 2. Putting all of those together, the complete solution is x equals n multiplied by pi over 2, where n is any integer. And that's the entire puzzle. Instead of wrestling with enormous powers, we let a simple inequality do all the hard work. If you enjoyed this elegant trick, don't forget to like the video, subscribe for more math puzzles, and I'll see you in the next one.